In this video, I am working a problem from the homework. It's from Chapter 6, Section 1, and it's a problem ID number 6.1.5. It's asking about a probability given a uniform distribution. So I haven't written down the entire problem statement, but I wrote down everything that sounded most important to me when I read the problem statement. It told us in the problem statement that we were dealing with waiting times that deal with subway departure and passenger arrival. And then they told us that the waiting times were uniformly distributed between 0 and 6 minutes. All that means is that if you are just some passenger arriving at the subway and you're not sure how long you're going to have to wait, this is just saying that it's equally likely that you might have to wait 0 minutes as it is likely that you would have to wait 1 minute or 2 minutes or 3 minutes or 4 minutes or 5 minutes or 6 minutes. All of the possible wait times are equally likely between 0 and 6. So if I want to graph this distribution, I'll graph it like this. So there's a wait time of 0 minutes, there's a wait time of 6 minutes. Now we need, since all of the probabilities are equally likely, this uniform distribution is going to be rectangular because all of the different times in here are going to have the same probable outcome. So this curve is just a straight line. It's going to look like this. And we need the total probability, the probability of waiting between 0 and 6 minutes, to be exactly 1, because you have 100% wait, or you have 100% probability of waiting somewhere between 0 and 6 minutes. You're going to wait between 0 and 6 minutes if you show up for this subway. So we need the area under this curve to be 1. So total area, for total area to be 1, so this is going to be length times width, and that has to equal 1. The only way that will happen is if 6 minutes times the length is equal to 1. Now I wouldn't worry too much about the units here. Or I said length. I guess what I mean is width. Sorry. So 6 times that width, or that height if you prefer, has to be 1. So we'll divide both sides by 6. You can call it width or you can call it height. Width has to be 1/6. So this is 1/6. And again, remember the reason why we're doing that is because we need the area under the probability distribution to be 1. And we need the area under this probability distribution to be 1 because a probability of 1 means we're absolutely certain it's going to happen. So the probability of something happening, the probability of somebody waiting between 0 and 6 minutes, if everybody waits between 0 and 6 minutes, has to be 1. So the area of this little rectangle is 1/6 times 6, and 1/6 times 6 is 1. Okay, so that's that. Now here's the question. They ask us, well, what's the probability that our wait time would be greater than 3.25 minutes? Well, they're basically saying, okay, let's say here's 3.25 minutes. What's the probability of having your wait time between 3.25 minutes and 6 minutes? Well, the probability turns out to be the area under this curve. You just take the 3.25, or you take this distance and you multiply by this distance, and the area under the curve is the probability that your wait time is going to be greater than 3.25 minutes. It should be 3.25 and then everything to the right, but it only goes up to 6 minutes. So it's just going to be length times width. And that's going to be 6 minus 6.25 minutes. Or I wrote 6.2. I said 6.25, I wrote 2.25. It's 6 minus 3.25 minutes times the width or the height. Either way, whichever you prefer, you can call it. It's just this dimension times this dimension. So this is 1/6, and then this is 6 minus 3.25. So we take the large number and subtract the smaller number. So we get 2.75 times 1/6. Sorry for the glare. And I get 11 over 24. I want a decimal approximation. So I get 0.4583 repeating. And then let's look at the Pearson website and see what they want. It looks like the Pearson website wants, I'm sorry, I have to move my camera away. And they want us to round to 3 decimal places. So because this 3 is less than 5, we're going to round to 0.458. So that means, we can move the decimal over twice, and interpret this as a percentage. So the probability that you're going to wait 3.25 minutes or more is 0.458. So like 45.8% of the time, you're going to have to wait 3.25 minutes or more at this particular subway, where everybody has to wait between 0 and 6 minutes, and all of those times are equally likely.